Lesson 2. What are the landforms of glacial erosion? A quarry is an armchair-shaped rock hollow with a steep back wall and an over-deepened basin with a rock lip. It often contains a small lake known as a tarn. In the British Isles, quarries are mainly found on the north, northeast and east facing slopes where reduced insulation allows more accumulation of snow. If several quarries develop in the highland region, they will jointly produce other erosional features. When two quarries lie back to back or alongside each other, enlargement will often leave a narrow, steep-sided ridge between the two hollows, called an arête. An example is Striding Edge on Helvellyn in the Lake District. If more than two quarries develop on a mountain, the central mass will survive as the pyramidal peak, which often takes on a very sharp appearance due to frost shattering. An example of this is the Matterhorn in the Alps. Quarry formation is the result of several interacting processes. The original process is believed to be innervation, which acts upon a shallow pre-glacial hollow and enlarges it further into a quarry. This may take a long time and be spread across several glacial periods within an ice age. As the hollow grows, the snow becomes thicker and is increasingly compressed to form firn and then ice. The back wall becomes steeper through the action of plucking. The rotational movement of the ice, together with the debris supplied by plucking and frost shattering on the back wall, abrades the floor of the hollow, which over-deepens the quarry. As the hollow deepens, the thinner ice at its edge does not produce the same amount of down cutting, and a rock lip develops on the threshold of the feature. Some thresholds have their height increased by morainic deposits formed when the glacier's snout was in that position. After the last ice has melted, the quarry fills with meltwater and rainwater to form a small lake or tarn. Glacial troughs and associated landforms. Glaciers flow down pre-existing river valleys as they move from upland areas. They straighten, widen and deepen these valleys, changing their original V-shaped feature into a U-shape typical of a glacial erosion. The action of ice combined with huge amounts of meltwater and subglacial debris has a far greater erosive power than that of water. As both extending and compressing flow are present, the amount of erosion varies down the valley. Where compressing flow is present, the glacier will over-deepen parts of the valley floor, leading to the formation of rock basins. It is also suggested that over-deepening is caused by increased erosion at the confluence of glaciers, areas where weaker rocks or zones of well-jointed rocks. The major features of glacial troughs are: 1. They're usually fairly straight with wide bases and steep sides, a U-shape. 2. Stepped along profile with alternating steps and rock basins. 3. Some glacial valleys end abruptly at their heads in a steep wall known as a trough end, above which lies a number of quarries. 4. Rock basins filled with ribbon lakes, for example Wastwater in Lake District. 5. Over-deepening below the present sea level. This has led to the formation of fjords when sea levels rose above ice ages and submerged the lower parts of the glacial valleys, for example on the coast of Norway and southwest New Zealand, Milford Sound. 6. Hanging valleys on the side of the main valley, for example the Valley of Churchbeck, which flows down into Coniston Water in the Lake District. These are either pre-existing tributary river valleys which were not glaciated or tributary glacial valleys. In tributary glacial valleys there would have been less ice and therefore less erosion than in the main valley. The tributary valley floor was therefore left higher than that of the main valley when the ice retreated. 7. Areas of land projected from the river valley side spurs have been removed by the glacier, producing truncated spurs. 8. Small areas of rock on the valley floor are not always completely removed, and this leaves roches moutonnées. These have an upstream side polished by abrasion and a downstream side made jagged by plucking. 9. After ice retreat, many glacial troughs were filled with shallow lakes, which were later infilled, and their sides were modified by frost shattering and the development of screes which altered the glacial U-shaped. For example, Great Langdale in the Lake District.